Again, good morning everyone. So I really appreciate you join this GM course second day. And now we are truly honored to welcome Dr. Tamura Khan as the first speaker of today, day 2 of this ongoing one-week GM course. Before takes a stage, I'm very honored to introduce him to all dignitaries and attendees. So Dr. Tamura Khan received his PhD in electronics and communication engineering from NIT Patna in 2014. And he joined NIT Silchar at the same year as assistant professor, and it's currently associate professor in the Department of Electronics and Communication Engineering. He has also served as a visiting researcher at the Queen University, Canada, 2019 engineering. And he has also served as a visiting researcher, Canada, and a visiting associate professor at the Asian Institute of Technology in Thailand, 2016. And before NIT Silchar, he works in the various institutions for over 20 years, including more than 3 years at the Delhi Technical University. And at the NIT Silchar, he has held key administrative roles such as head of EEC, associate dean, and associate warden, etc. And currently, he is a member society of the DPMC program coordinator of MTech RFTC, and lab in charge of the advanced antenna and RF laboratory. And his research interest includes RF energy harvesting, WBT, UWT antenna, and EPG structure, the electric resonators, and AI, ML for electromagnetics. He has graduated, he has guided 8 PhD theses and authored 90 journal papers, and 73 conference papers, 3 patents, and 6 very excellent. He has completed 6 funded projects, and is currently executing 3 international collaborators under SPARC and VAJRA with Queen University and California State University, Northridge, USA. And he is a fellow of IEI, IETE, and MTS, and a senior member of the IEEE, ME Society, MTT Society, and UC Belgium. And like member of the ACES, he served as associate editor of the IET electronics letters, and IJRFM CAD Hyundai Mobile, and editorial board member of the Nature Science Report. So his technology and educational contribution are very, very good. So today, this is his topic, and please enjoy his lecture. Thank you so much.
Thank you very much, Professor Naoki Shinohara, for this wonderful introduction of the speakers, for first speaker of second day of this ongoing GAN course. Like, I need to create a link first. What we listened yesterday in 3 different lectures. That was the review of different aspects of WBT. Okay. Now, hopefully, it will be the first lecture of this ongoing GAN course, which will give you the fundamental aspects first, and later on is Professor Naoki Shinohara will continue to the more advanced topic for that one. The topic for this talk is microwave power transfer applications in medical applications, or especially in the biomedical domain, which I will be going to focus in this lecture. That is only that WPT or microwave power transfer aspects in that wrist wearables, which have been very popular gadgets nowadays for monitoring the different health parameters as a smart wristband or a smart watch. Okay. Before going into the technical content of my talk, it's a brief overview of me. Those who are like belonging to the same institute, this is no meaning of this slide for them. But for outsiders, like we are situated in the northeastern part of country, where the institute is situated in Silchar town. On the bottom side, you can see the aerial view as well as the campus, that our own building where we are conducting this Gyan course. Then on here is the strength of my department, that we are having total 34 teaching faculties, including all cadres of the positions, like training teachers to Professor Hack, which is the highest one in the academic institution. The department was started in the year of 1983 with an intake of 20, and presently we are having an intake of 180 UG students. And the first, very foremost, that the PhD program was started in the year of 2004, and the later first MTech program in microelectronics and VLSI domain, that was started in 2007. Then second MTech program in communication and signal processing in 2013. And 2 years back, we have started the third MTech program, that is RF and Arts communication, in 2023. Now coming to the main content of my talk, that you see the scenario what is happening in upper two images, that the first one or figure one basically giving the glimpse of complicated scenarios of connecting the wires in transmission line, especially the power lines. And second one is basically that is the overview on that pole when we are connecting the different communications lines. Okay. Then if you see this one, then apart from connectivity, that is the advantage of that one, but there are certain issues with this type of wired communication, wired lines, wired transmission, wired power lines, as well as wired communication lines, that they requires the maintenance cost very high, and that ultimately that the installation cost is also high, then the transmission loss will be very high to that one, and the installation period will also be very large as compared to that present day any Wi-Fi connection. Within few minutes we can install that one in our home. Okay. Then huge construction waste will also be there at the time of installing these structures in our homes or in other premises. And the third one, the last one, is basically that is going to enhance the e-waste also. Just see the scenarios of e-waste that we can visualize easily, that it is this type of waste is dumped somewhere in our homes at the time of doing that electrical connections, as well as in academic or other organizations when it is to be installed in a very big premises of that particular department. That a huge amount of waste will be there, and when that waste remains for a longer period of time, then it starts to decompose very hazardous chemicals that basically affects the human, that basically affect the different organs of humans. Okay. Then on right hand side you can see that what specific chemicals is going to harm to specific organs of our body. Now the question is, can we think about a wireless power as we are having presently in 21st century wireless internet? The answer is yes. We can say yes, and the same things came into the mind of Nikola Tesla in the year of 1989. Okay, that he take it as a challenge that if there is a possibility of wireless, if there is a possibility of making that power wireless. Okay, now I'll go briefly in the history of that period of time when Nikola Tesla did an experiment. In that way, it was the period of mid-80s, 1800 in United States, that three popular terms, one is the electricity, telephony, as well as telegraphy, were getting popularity, and the three genius names behind this technology were the Thomas Edison, Alexander Graham Bell, as well as Norman Reed. They established the American Institute of Electrical Engineers in the year of 1884. and later on means that is further extended, merging with the Institute of Radio Science in 1912, and finally the IEEE Institute of Electrical and Electronics Engineers came full-fledged in the year of 1963. Now go back to that period. In 1864, James Clerk Maxwell have given the idea of that electromagnetic waves. Okay, then how it was there and that other things will not be possible to be discussed here. Then later on in 1884, that Poynting has quantified that amount of energy by introducing the concept of Poynting vector. That is nothing but that instantaneous power corresponding to that electromagnetic waves is the vector product of electric field and magnetic field. That was the quantification or quantified version of that Maxwell's introduced in the year of 1884. Later, 3 years later in 1887, Hertz did investigated the existence of electromagnetic waves in the laboratory environment. Okay. Later means in 1901, Marconi did that experiment between the two different ends. One was in England, another was in Ireland, for making a successful transmission of telegraphic signals. And finally, he himself has given the idea of wireless first time to the telegraphy signals. Telegraphy means that is present day fax. Telephony means present day that what we are having mobile phones and other. That is the refined version of earlier telegraphy and telephony. Then in 1989, that Nikola Tesla has taken that idea in the different ways. While there is a possibility of having that wireless power, and keeping that idea, he started doing some experiment. That experiment is basically got very much popularity in that period of time, and finally it was also dumped due to certain problems in that experiment. Just a brief of that experiment, that he actually built a huge coil, that is Tesla tower. On the top it is 3 meter diameter that coils, and that 200 feet the height of that one, and cost of that project was that period is 30,000 USD. Just see that one, it may be very huge amount in 2025, and he could able to feed that 30 kilowatt of power, and finally he was able to radiate that power to lit the 200 lamps within perimeters of 40 kilometer region. But there were certain problems with that one, that the radiated power was diffused in all the directions. That was going to harm to the human life in that particular region, because there was no way of making it concentrated in specific directions because of lack of technology development in that period of time. And another problem with that one, that the investment of 30,000 USD was quite large, and it is very high as compared to the making wired connections between the same periphery of 40 kilometers. It was very expensive as compared to the traditional wired connections in that same period, same regions of that way. And finally means that idea was went to the dustbin, and during that World War first, US government destroyed the towers also. And later means in the same period of time, if you are interested, then you can take a Google of why this war, the current war, the war between not scientific war between Nikola Tesla and Thomas Edison. That will give you a different perspective in that period of time, and finally who won that war and who was failed in that war, that is a different way. Okay, one movie was also, science fiction movie was also created on the same title, The Current War. If you are interested, you can go to that one, into the detail. Now coming back to that Nikola Tesla and its continuity in the period of 1960s. Before 1960s, if you recall, that World War First has happened, later on World War Second also, because during the war, several technology are tested and finally means come to a way to upgrade that existing technology for the future reference. And that was the period when William C. Brown in 1964 took the idea of Tesla and to further improve that one. What was the problems in the Tesla experiment in 1884? He has taken that reference, and finally based on, because that was the period when high power source was also developed. That is in 1916 that magnetron was developed. That is high power source, and Ecclestone's tubes was also developed in the year of 1937. That was the reference, means to transfer that 150 kilo low frequency signals, low frequency transmission to some higher frequencies. Okay, then ultimately he could make it possible in the year of 1963 for making a device what he himself given a name of rectifying antenna, basically antenna plus rectifier, and with that setup he could make it possible for getting an efficiency of 50% for output power of 4 watt and 40% at an output power of 7 watt. And the same period of time he did several experiments. Then finally, if we see that here you can see that a photograph where he is like testing that helicopter as well as that aeroplane to that period of time, while keeping that very huge amount of rectangular array on that way. But the problem with that experiment that time was the cost. Okay, now due to the development of several things related to electronics domain, then now the cost has also been reduced up to certain level, as well as the size of that one. Day by day, new things are coming in the form of upgradation in the IC technologies. But huge circuits you are having in a very big breadboard, now it is possible to have that one in a very small ICs. That's why the size of entire systems is going to be reduced. You recall your first generation of mobile phones where the antenna size was quite large coming out from the body of that one. Now in present day smartphone you will hardly find where is that antenna. It is inside that entire box. Okay, and maybe next versions of mobile phone, there different like extensions will come in the form of like fully transparent, wearable, tearable, stretchable kind of electronic gadgets. That is the day by day upgradation in the technology. Okay, here we can see the early reference of William C. Brown and his associated group in the period of time 1969 to 1992. Just a reference coming to the things, because the rectangle ultimately is the associated with two terms. One is antenna, second one is rectifier. The overall performance of antenna, so rectangle will be defined the performance of antenna plus the performance of rectifier. Okay, or these two are having different work. One is to capture that electromagnetic waves from the atmosphere, and second one is to convert that one in the form of useful DC. Okay, then like for improving the antenna performance, that what we need to do, we need to induce the high amount of gain within the antenna elements, as well as sometimes the large bandwidth, then single band to multi-band characteristics will also be required. And the power conversion efficiency, that is directly linked, because that conversion efficiency is highly dependent on frequency where we are going to rectifications. Okay, then because of that one, several things that we need to take as a challenge for improving the performance of overall rectangular systems. Hereafter, we can see that few observations of taking 150 kilohertz frequency in Tesla experiment. Because the idea behind taking that low frequency, because he was having a perception that radiated power from the Tesla tower will take a path of ground wave propagation. And the ground, that earth resonance was happening nearby to that low frequency, that is 7.8 hertz, which is known as the what they call that that is the heartbeat of earth. Okay, that is 7.8 gigahertz. That's why he has taken that reference of taking low frequency. And another reasons of taking that one, because the source for higher frequencies were not available that period of time. That was another reasons. Okay. And the third may be that because of low frequency, that ultimately that radiation losses will be low as compared to high frequency. While taking of 2.45 gigahertz by William C. Brown, that certain like advantage of taking that one, it is an unlicensed band, unlicensed frequency band, and several means like once you are going to higher frequency, then wavelength will also be reduced, and by taking that lower amount of wavelength, then overall size of the system will be reduced, and some other way that RF to DC conversion efficiency will also be enhanced to that one, and another means that is the line of sight transmission is possible to that by taking the 2.45 gigahertz. Now coming to the three like more, sometimes we use the term WPT, SWIPT as well as how it is linked to that radio frequency energy harvesting. We start from the basic way of defining that wireless power transfer in the near field as well as in the radiating far field. If you take that near field reference, then ultimately near field reference, then you can see the classification in this way. Okay, but we need to focus that radiative far field in that way. Laser power transfer as well as microwave power transfer is the classification of two way for defining that wireless power transfer, and we need to focus on that microwave power transfer here. Coming to the two different way of like near field, one is inductively coupled WPT, second one is capacitively coupled WPT. So the two different examples that I have put here for correlating the gadgets available in present day. One is your that wireless charger, mobile charger, and second one is like charging stations for electric vehicles. Okay, then you can correlate to this one, that is ultimately having an inductive coupling as well as to the capacitive coupling. Coming to that far field way, that there is a things that there will be a dedicated source and you need to utilize that energy from a distance. The distance between the source and that observation point in earlier two cases is very small. Now it will be having quite large distance, and the things are that the availability of amount of that source and your skills in developing that antenna systems within more, so that it should be very efficient in the form of size, in the form of that your electrical performance. Okay, the glimpse of that one that I have tested here, that is based on our own students work, and it was tested in our own laboratory here. Coming to that block diagram for these two, WPT, RFEH and WPT, if you see that one, this side is almost same, there is no much difference. Difference is only to the input side, that one is having a dedicated source, second one is having an ambient source. Okay, then according to that availability of source, then ultimately we need to take few changes in designing that antenna part. If it is ambient source, then we need to take care of that improved performance for lowest possible amount of energy available in the atmosphere. If it is having some certain dedicated source, then the amount of energy will be high, and you need to tackle to that amount of high energy for converting that one into the useful power. Here you can see few sources that we are surrounded these type of sources in our environment. Okay, these are maybe that ambient source and different frequency range that you can see here. That are the different sources available. And finally, three different example you can see that RFEH powering to LCD, and RFEH that quartz clock, which itself is a metallic structure itself sufficient for generating the power for that clock. And here some temperature humidity sensors with RFEH systems, RFEH powering, that is just for reference. And a quick means SWIPT is basically that is having the dedicated transmitter which will send the information as well as the power simultaneously, and it will be received by that receiver, and finally it is split into two parts. That information will go to a specific direction and power will go to that the net amount of power will be split into two different ways. Okay, then power ultimately at the transmitter side, if you are having multiple source, then you need to combine the power, and at the receiver side, if you are taking that power as well as information simultaneously, then you need to split that one. Okay, then this is the basic view of taking these two different ways. Now coming back to this, I can skip because I already told you that we need to focus only this part. Then here just see that comparison of power density available in four different cases. In RF case, that density is lowest one, but the uniqueness of that power is it is available round the clock, 24 hours it is available to us. That is the capability of this ambient RF source that we need to utilize, and that power, if we utilize efficiently, then it is capable for using that IoT devices as well as sensors available in our used in our daily life. Okay, then three different sources to this way. Coming to that spectrum, because if you take the reference of 5G, ultimately different sources that I already discussed, then 5G two parts, sub-6 gigahertz as well as millimeter wave, and the different countries are having their own different extent, because in RF we need to play with the frequency, and what specific frequency it is like defined country wise. In India it is having some different range of frequency, in other countries it will be having some different range of frequency. Basic things of rectangle in context of WPT, in context of RF is that you can take it for further detail. You can refer this review articles for. Now coming to that rectangle key components. What are the different key components of rectangle systems? The first, we need to see this block diagram, basic fundamentals of fundamental block diagram, that it is having an antenna system, then input filter, matching network, rectifier and storage element. Sometimes this storage element is not mandatory. If you are directly feeding this rectified power to the load, then its requirement will be not required. But ultimately sometimes you need to keep reserve that power taken from that ambient source or dedicated source. For that one, energy storage systems or device or circuit will come into the pictures. Okay. Now, for improving the performance of an antenna, because in other than RFEH and WPT application, we can see that miniaturization is important for antenna design, and high gain multiband characteristics as well as the broadband characteristics. Then several techniques are available and new ones are also added into for improving the gains, improving the multiband characteristics, improving the miniaturizations also to that way. Hereafter, we can think about the next element, that is rectifiers. In rectifiers means we are having two kinds of series available. One is SMS series, which is used for low power rectification, and second one is SMS series, which is used for high power. Then low power rectification will come when you are having an ambient source, and high power rectification will come into the picture when you are having a dedicated source to be rectified. And certain means reasons of selecting by Schottky diode, because it is having the fast switching, low forward voltage drop and high conversion efficiency also. But when we move to microwave to some higher frequency, then it is not the best choice to use that Schottky diode. For that one, we need to take some other means of rectifying device that may come in the form of CMOS, then FET also. Okay. Then different topologies, that in traditional like basic electrical engineering we see half wave rectifier, full wave rectifier, bridge rectifier, something. All topologies are used here also, along with some other advanced topologies, which ultimate purpose is to make the efficiency of that rectifier as high as possible for high amount of that input, high frequency signals available at the input of that rectifier. The few ones are here. It is an overview of the different rectifiers. Then you can refer these to review on this, especially for that rectifier. Coming to that classification part, in context of that one WPT and RFEH, you can see that it is based on topologies. Then it may be a series rectifier, shunt rectifier, voltage doubler, then ultimately charge pump, nature. Then based on rectifying device, it may be either diode based, it may be either of transistor based. Then coming to that operating conditions, this is very much important as far as RFEH and WPT is concerned. Based on operating frequency, it is on single band or multi-band, broadband. Okay. Then based on operating power is very much important for that one, because it may be low power, it may be high power. Okay. Based on that one, you can see that classification: low power rectifier, high power rectifier, and a wide dynamic rectifier, in the sense where the power variation is changing. That strength in case of ambient source, it is always changed. It is not fixed for all the cases. It is changing. That variation in received power you can see in your mobile phone signal strength. Sometimes you are having complete 4 or 5 bars, and sometimes it's only 1 bar and 2 bar, 3 bar something. That is the variations or range, that power range variations in that way. Then finally means that is very much important kinds of rectifier to be taken care in case of WBT systems. Impedance matching network is another important aspect, because you need to play with the dedicated energy available as well as to that ambient energy available. For that one, the impedance matching between the antenna as well as the rectifier is very much important. Okay, for that one, impedance matching networks will come into the picture. They may have these reference topologies, or maybe different other new or novel topologies are available in the literature. But the ultimate purpose of this one is to provide that impedance matching between the antenna as well as to the rectifier one. Then what will happen if there is a mismatch? Then you can easily correlate by the maximum power transfer. Okay. Then ultimately, to make that one maximum power available at the antenna part to be delivered to the rectifier part, we need to have the perfect matching. Okay. And sometimes this matching is not required. Inherently, we induce that matching concept within that antenna as well as to that rectifier jointly. That's why in several papers you will see that inherent matched rectangle word. It means no additional impedance matching is required. Sometimes it usually happens in different literature, different papers. You can see that how it happens. In case of only, you will see that this part is antenna, this part is rectifier. Jointly it is giving the concept of U for complete antenna one without additional incorporation of impedance matching network. Hereafter, because in case of that one ambient source, there will be the multiple frequency source available in your surroundings. Okay, that may belongs to 1, 2 or number of more than one sources in this way. Now you need to take that energy to harvest, and finally you need to convert that into the useful power. In that way means power combiner will play a significant role. Okay, if that ambient energy or that energy is low in volume, low density, then first you need to combine that energy to make it suitable for rectification. Okay, then one classification of combiner will be there. That is that one, that first combine, last rectify. First combine means that is you need to make that small energy to combine first to make it suitable for like exciting that rectification characteristics, and finally if it is sufficient, then individual elements will rectify. And finally that combine will happen in the form of DC. Okay, that is the two different topologies used for power combiner. One is DC power combiner, second one is AC power combiner. Apart from that, like you can see the different energy storage means batteries, different classification of batteries are there. Apart from that means supercapacitor, which is low in size but having certain limitations of storing capabilities. That's why both are having the scope of research. One is to make supercapacitor to retain very large amount of energy, to design a battery of, because battery is thick as well as a large volume, to design a battery to retain that large amount of energy as well as that low volume. Okay, then both are having their own like scope for exploring the research in context of WPP. And the last one is power combining, power management unit, because you have seen that fluctuations in the input side in case of ambient source. But your device, what you are using as a wearable device or other means of sensor, it requires a constant amount of power. That's why the essential requirement after rectification is to make this stable power. For that one, sort of voltage regulations that is done in case of in addition to several other features. That for we use only that one, that is the power management unit. In that way, hopefully the detail of that one I will be discussing in the next way. coming to that wearables presently available for medical as well as healthcare applications and their power requirement. Starting from traditional wearables, what we have in the form of HMT watch, long back, okay, then presently we are having a smart watch concept and electronic watch concept. It was only giving you the idea of about time, but present day smart watch is giving you the complete your health profile. Okay, that's why in case means how that upgradation is taking place. If you see that all these ones are based on that traditional battery, in the month or 2 months, 3 months, 6 months later means you need to replace that one regularly. Okay, but several things are there in the form of smart, like present day smart wearables, which are capable of giving you your health parameters. Okay, like you can take the reference of any specific brand of that one. Then vocal function, restoration, the different health features that you can take with the help of wearables. Okay, maximum health profile will be in the form of that one. Then what is the difference between these devices to the earlier wearable? Earlier was having a dedicated source of power, that was the dedicated battery. Now all these are based on that rechargeable. That fixed battery is replaced by rechargeable. Okay. Then once it is making possible rechargeable, then because day by day means that amount of power consumption in the traditional wearables was high as compared to these ones. Okay. Then one way means to reduce that power requirement to a certain levels. It means the scope of having or making that individual device operating at low frequency, low power. That because overall circuit is the composition of 100 number of devices, 100 number of circuits or elements. Okay. In that way, you need to make that single IC. Presently, you are having 5 volt. In near future, you can have 1 volt operated or similar amount of that one. That's why it is having a chance of exploring the things in the form of that one, starting from the traditional wearables to that present way. Somewhere means their body attached devices we are having nowadays as a wearable only on the body surface. In future, you may have that one in the form of implantable inside the body. Like if those who have attended that earlier GAN course, that was artificial kidney implant. That is some electronic circuit. It is going to replace the natural form of kidney, and that electronic circuitry will require a power for operation. In that way, because it is not possible to keep that battery inside the stomach and regularly 1 month interval you are taking out that battery and changing that one. It means some other means of power requirement, power mechanism is required for that one. That is with the help of that outside device will have that capability to sending the power also inside the implant for that one. And other extension that you can see that implantable as well as ingestible devices. Ingestible electronics is the future of electronics way. Okay, that is ultimately here you can see the scope of wearable technology market. That is just an overview. Quickly I can remove because I need to focus only that. Based on the power requirement of the smart wearables, we can classify that one under 10 milliwatt power requirement. Different gadgets are there. Then medium 10 to 100 milliwatt power requirement, and last one is that is high. High means high. No, high does not mean the power which we have seen in yesterday's last 3 lectures. It was quite huge power. Okay. Then ultimately it is less than a watt classification of power requirement of different variables. In that way, that is need to say bye-bye to this traditional battery, come to that some alternative for making that one self-sustainable kind of solutions for this way. Okay, then for that way, that energy harvesting is a suitable alternative because of several drawbacks for that one. Then here you can see that different views of making that energy, that human body, that different organ, that movement of that one, if we are capable of making that suitable device to convert that moment into the useful power, then ultimately that power will be sufficient for charging our gadgets available with us in the pocket or nearby to our house. and different RF sources that you can different like devices or have already been used in the environment that we can make them possible to the energy to that one. Quickly, this has already been like discussed to finally. Just an overview of this one, and coming to that illustrative example in the same theme, that how to make that wearable device capable of on that one your wireless power transfer of or energy harvesting to that one ultra thin flexible antenna integrated with power management unit for power harvester charging of a smart watch or wristband. Just see the scenario that the same wearable, it is having two kinds, that is that coil based or touch pad, and it is another solution to that one to insert one antenna inside this one, and it will be capable to take the energy from the atmosphere, or it may, if ultimately the position of this watch remains fixed somewhere in the home, maybe very elderly people, then it may be placed behind that one dedicated source of power, because each home is having 2.45 gigahertz Wi-Fi in our way, then that may be treated just like to a dedicated source. Okay, that source will radiate the power and will be capable of converting that power in the form of that DC, which is required for the operations of this wearable. Here, starting from that antenna, that you can see that it is ultimately this staircase ground plane, that structure is used, and how it is coming, and how the required performance we have achieved in the form of upgradation in the antenna part, as well as the multiplier 1, that antenna 1, then antenna 2 upgradation, 3, 4, this one. Okay, then what material is used for this one, that is biocompatible polyimide substrate. Okay, the size is very compact as compared to that available literature, and the different dimensions what we have optimized for this particular designs are mentioned here. Here you can see the performance of all these four cases, that how the reflection coefficient performance is changing with respect to frequency. Then our target is to make it tuned at 2.45 gigahertz. Okay, then just see that fourth one, antenna 4 and antenna 1 to 4, how it is gradually reducing to make it tuned at 2.45 gigahertz. Here you can see the performance variations in the form of change in the ground planes, that is staircase ground plane, how it is achieved, step 1, step 2 and step 3. Okay, then ultimately how the performance is changing in the simulation as well as to that final means measured one. Then it is 2.6 gigahertz in step 1 here, and 2.45 gigahertz in step 3 to this one. Now circular polarization is induced because the two different very common approach are available. One is corner truncation or sometimes asymmetrical cross load. But there was no way of introducing these two techniques here because of shape of this radiator what we have optimized. That one copper, a large amount of copper you are having here, then we have tried to utilize only this way to truncate or to convert that one in the form of rectangle slot, and that slot of 3 mm by 3.1 mm was sufficient for generating the circular polarization for this particular design. That is ultimately that proposed antenna with circular polarization, and just see that one variations in the form of axial ratio versus frequency. This is that surface current distribution for this design at WT equal to 0 degree, 90 degree, 180 degree and 270 degree. That power management unit, that one, and its equivalent circuit, ADS equivalent circuit that we have used here, and finally means it is that purpose of this power management unit I have already told you in earlier discussion. Coming to that rectifier one, means we have used SMS diode, Schottky diode with this one, and it is available in different topologies, and for us we have used only that VM, that is voltage doubler or voltage multiplier topologies, and ultimately in that way that other components values for this one that is optimized here with these values, and that radial stub is used as a impedance matching purpose for that one. Now here you can see the equivalent circuit concept of that antenna and rectifier. If that way, then different means that mathematics can be like seen in that reference paper, and finally means we are having a comparison of antenna rectanna performance comparison reflection coefficient, that is antenna only, rectanna, then equivalent circuit model, then measurement, all are giving a convergence for the same observation point 2.45 gigahertz. Then here that because bending will also be a very much important factor, that we have taken the three aspects. One is 0 degree, then 10 mm circles, then 20 mm circles, and 30 mm circles, and how the performance is changing with that way, that before bending at flat r equal to 0, then the bandwidth was 1.43 gigahertz, and after bending that 20 mm, that bandwidth is reduced to 1.24 gigahertz. Then ultimately peak gain are almost within that range after applying that bending effect to that one. Because another important factor is because it is to be touched on the human body, that SAR analysis is also equally important. That is done here, that how, because skin layer, then fat layer, then muscles layer, this is the thickness and model tissue model characteristics for these three different layers, that is use that simulated SAR values 1.22 watts per kg for 20 dBm, and this one as per standard, that is within that range. And here you can see that SAR distribution characteristic. And coming to that power conversion rectifier part, that power conversion means P in versus output voltage, that we can see that ultimately is 0.98 volt measured in indoor environment, 2.46 volt outdoor, and 3.30 volt in outdoor with PMU, and like for an input volt range to 0.8 to 5 volt. It is fixed 3.3 volt with the variations in input volt 0.8 to 5.5 volt, and the maximum power conversion efficiency that we have achieved in this way, that is 78.2% at the input power level of 0.5 dBm. Here because that is to be placed on the human surface, wrist surface, that's why the parasitic element as a reflector is placed at the bottom side, and how the performance is changed to that one while maintaining a distance of 9 mm, 11 mm, 12 mm. That radiation patterns for this then measurement setup on different. Then coming to that conclusion part, that is ultimately the proposed antenna characteristics as compared to that reference literature, and proposed rectanna part as compared to that reference one. Then here because it was one like work based of our students group here, and there are several other work that we have developed for antenna design part, then ultimately rectifier ones, then complete rectanna systems, complete rectanna ones. Then here because 5G rectanna is playing a significant role for biomedical application. Okay, then a beautiful summary of existing literature of 5G as well as the millimeter wave rectanna that you can find out in this review article, which was published in an IEEE antenna magazines in the year of 2023. Then just a glimpse of few geometries for sub-gigahertz antenna geometries quickly. Then few rectifiers topologies for sub-gigahertz WPT, RFEH, both. Then antenna geometry for millimeter waves, different way. Then antenna rectifier configuration for millimeter waves applications. Then for millimeter wave WPT, especially antenna geometry for millimeter wave WPT applications. Then rectifiers for millimeter waves. Then rectifier configuration millimeter wave, especially for WPT applications. Then ultimately coming to that, towards that conclusion, that there are certain challenges when we are designing rectanna for like low power requirement. Okay, because of compactness you need to accommodate your complete retina system within the prescribed size of the device. So your retina should be smaller than the size of that wrist watch. If it is bigger than to that one, then how will you put inside that one? That is the thing. Each and everything you need to accommodate inside that one. And same thing is for rectifier, because challenge for antenna part, challenge for rectifiers to that one. Here means like opportunities that we can think about to create the WPT or RFEH for implantable medical devices, especially the wearable one of them I have discussed here. Then remote health monitoring systems, that we can make it self-powered while incorporating that RFEH concept. Internet of medical things, then wearable power, so non-invasive and wearable power source. That non-invasive medical devices played a significant role during COVID period, where doctor was having a fear of touching the wrist for observing the pulse. It was each and everything was to be observed to a distance. That non-invasive, different non-invasive devices came in that period of time. Okay, here means just a reference that global like that retina classifications according to the type, according to applications, according to range, and different key players of retina who are developing that commercial prototype for retina. Here are few references of our students group here at NIT Silchar. Then on rectifiers, then on review and publications on rectifiers, then same means RFEH WPT, that publication on antenna rectina, then few only that conference in the last 1.5 years, then two reference in the form of two edited books. One was published in 2020, second one is 2024, and it is an honor for me that I am associated with third proposal along with Professor Naoki Shinohara. In the months to come, hopefully it will be published. Okay, that is especially for helpful for these emerging areas. Then acknowledgement, because apart from that students involved, because students at UG, PG and PhD are the backbone of any research activity in any academic or research institutions. But along with that one, funding is also essentially required. These are the funding source that we have got from that one. Some of them are still going on, and still some of them are completed to that way. With this, I conclude myself, having 2-3 minutes in my scheduled time. Then we'll be happy to have few queries.
Yeah, so thank you so much. So it's time for question and comment and discussion. So if you have some question, comment or discussion for him. Yes.
Sir, around slide number 50 to 54.
Yes.
The reflection coefficient
52.
back. हाँ,
Okay.
इसके पहले वाला I think 49.
Okay.
So the reflection coefficient is showing that less than minus 20 dB.
Yes.
So we consider like minus 15 to minus 20 in reflection coefficient.
Yes, yes. Because that reference we generally take 10 dB, minus 10 dB.
But that is ideal condition which is simulated in the step number 3, the black one.
But other problem is you need to tune to that frequency. Your frequency requirement is 2.45 GHz. And in first case, that frequency is different to 2.45 GHz.
But the one more back, one slide back also. Why we have created then the antenna number 4? Because
Antenna 4 is for circular polarization. Up to antenna 3, you are achieving everything what you have. But in case, because you are having in that ambient source environment for that specific application, then circular polarization is also required for that. That's why fourth step is only for circular polarization.
so it will give better efficiency in terms of circular polarization.
Yes, obviously, if there is a mismatch in polarization, then definitely it will affect the final efficiency of that system.
But the antenna number 3 also I can give, it will not. Antenna number 3, the blue one, yes.
Yes, yes.
Because it's nearly the considered range of reflection coefficient.
Yes, but for frequency tune, 2.45 GHz, that is only here only. It is higher than to the 2. This one is 2.45. It is higher than to 2.45.
So we don't need to focus on reflection coefficient on that term.
Reflection, you are seeing that reflection coefficient amount in dB, convert it in linear scales, then it will be not much change. There is no much difference between the reflection coefficient of minus 15 dB to minus 20 dB. In dB scale, you are seeing that difference of 5, but in linear scale, it will not be going to give you any drastic change. 1 and 1.001, maybe something like. Okay, but in dB, if you convert that one, it will be a quite difference.
Because our circuit is based on antenna number 4. That's
Yes.
why we are taking it.
Yes, yes.
Thank you, sir.
Antenna number 4 with that tuned perfectly 2.45 GHz. Because our task is to design for 2.45 GHz.
Yes.
Yes.
Thank you, sir.
So do you have any other question or comment? If not, it's just in time. So
Yes, yes.
they have no question. Yeah, so it's time to close
Okay.
this.
Thank you very much. I was having a different fear for starting my talk because I learned this area while reading the papers of Professor Naoki Shinohara. It was a wonderful opportunity that today I am delivering in presence of him. But finally, with his blessings, it has been done perfectly. And anyway, thank you very much all of you for having the patience. Okay. Now I think we'll have a tea break of 10 minutes. After that, second lecture will be delivered by Professor Naoki Shinohara.